In this video, you're going to learn about arithmetic sequences. So when we say sequence, what we mean is a list of numbers in a particular order. So for example, 2, 5, 8, 11, 14 would be a sequence because it's a list of numbers and the order or the pattern is we're adding 3 every time, right? 2 plus 3 is 5, 5 plus 3 is 8, etc. Now with a sequence, we have what is called a term. A term is going to be each number in the sequence. So term 1 would be 2, term 2 is the number 5, term 3 is 8, and etc. Now in math notation, we can use the letter T to represent term. So T1 means term 1. So term 1 is 2. T2 or term 2 is the number 5. That's the second number. T3 or term 3 is the third number, which is 8, and etc. Alright, with sequences, we have different types of sequences. We have what's called a finite sequence, which is a sequence with a limited number of terms. So for example, this would be finite because it comes to an end. It stops at 1/4 and does not keep going forever. So because it's not infinite, because it does not keep going, this is the opposite of infinite, which is finite. So then the other type would be infinite, the opposite, which is a sequence with an unlimited number of terms, meaning it keeps going forever. Here is the same sequence, but at the end we see this dot dot dot, or what's also called an ellipses. This means that it keeps going on forever, which would make it infinite. So this is categorization based off the length of the sequence. So the finite stops and infinite keeps going. We can also categorize our sequences by the pattern. So we have what is called arithmetic sequences and then geometric sequence. And by the way, the word is pronounced arithmetic, not arithmetic, because arithmetic is a noun and arithmetic is an adjective describing the sequence. So different pronunciation. An arithmetic sequence is a sequence that is found by adding or subtracting to get to the next number. So for example, 10, 13, 16, 19, etc. would be arithmetic because I'm adding 3 every time to get to the next number. So that is arithmetic. If it was the other way, it's like 19, 16, 13, etc. This would still be arithmetic because I'm adding a -3 or subtracting 3 to get from one term to the next. Geometric is when I am multiplying or dividing to get to the next number. So for example, 4, 8, 16, 32, 64. Notice the pattern is that each time I'm multiplying by 2. 4 times 2 is 8, 8 times 2 is 16, and etc. So this would be a geometric sequence. And also if it was going the other way, so 64, 32, 16, etc., that would also be geometric because I am dividing by 2 each time, or thinking of that as multiplying by 1/2, same thing. So this would also be a geometric sequence. So in this lesson we're going to deal with primarily arithmetic sequences. So with arithmetic sequences we have what is called a common difference. And that is, by definition, what is added to get to the next term. And that is represented by the letter D. So D for difference. So if you have the sequence 10, 13, 16, 19, etc., you're adding 3 every time to get from term to term, so your common difference is going to be 3. And you may be wondering, why is it called common difference if you're determining what is being added from term to term? Because difference means subtraction. Well, that comes because to find what you're adding, you take each number. So if you take 13, if we subtract 13 minus 10, that would give me 3 to find the common difference. If we took 16 and subtract the number before it, which is 13, we would get 3 again. 19 minus 16 is 3 as well, and the pattern keeps going. So when we subtract one term by the other, by the one before it, okay, that difference is common. It is the same. And that common difference is 3. So that is where that number comes from. But maybe the easier way of thinking of it is asking yourself, what do we add to get from term to term? So if we had 19, 16, 13, 10, etc., the two ways of thinking of it, I could take 16 minus 19 to find the common difference. And that would be negative 3. 13 minus 16 is also negative 3. So the common difference would be negative 3. And the other way of thinking of this is, what am I adding to get to the next term? I'm going to add a negative 3 to get from term to term. So the common difference would be a negative 3. Alright, so make sure you know how to find the common difference given any given arithmetic sequence. Now here we are to find the common difference and then use that to find the next two terms of the sequence. So we got to find the pattern. Alright, so we find the common difference, and that is determined by seeing what we add to get from term to term. Well, we're adding a negative 5. Right? So our common difference would be negative 5 because that is what we are adding to get from term to term. So your common difference is negative 5. So if you keep the pattern going, the next number would be minus 5. So 30 minus 5 is 25, and then 25 minus 5 is 20. So we can use the common difference to predict the next two terms. Now here we are trying to find a given term if you know the pattern of the sequence. Now we could just keep adding over and over again to find a particular term in the sequence, or I can do a shortcut to find that term. So here we're trying to find the 100th term. So yes, we could keep adding 4 over and over and over again to get to the 100th term, but we want a quicker way to do that. So we see the pattern is we're adding 4, right? So 3 plus 4 is 7, 7 plus 4 is 11, etc. So we keep adding 4 over and over again to get to the 100th term. So the question is, how many times will I need to add 4 to the number 3 to get to the 100th term? So I start with 3, and then I'm adding a certain number of 4s. How many 4s do I need? So be careful. We see the number 100, but we're not adding 100 4s. We're actually adding 99 4s, because the first term is a 3 already. To get to the second term, we add 1 4. To get to the third term, we don't add 3 4s, we add 2 4s. So to get to the 100th term, we actually add 99 4s. So if I take 3 plus 4 times 99, that would give me 3 plus 396, which would equal 399. So that is the shortcut of finding the given term of a sequence. We start with the first term, so T1 for first term. Then we add the common difference, the 4. So common difference is letter D. And how many times do we do that? Well, whatever the term number is, we'll use letter N for term number. And we subtract 1 from that. So 100 minus 1 in this case was 99. So that's my equation. I can use this to find any given term. I take the T1 or term 1, add the common difference, times that by n minus 1. And that's my equation. So here we see it written out. Tn, that would be the nth term. So in this case, Tn would be T100. If we wanted the 50th term, this would be T50. So then we have T1 plus n minus 1 times d. So that's a little different than what I had up here. I had the d first, and then n minus 1. Here I have n minus 1 first times d. It doesn't matter because I'm multiplying the two numbers. And with multiplication, it doesn't matter the order. All right, so you can memorize the formula, or you can just think through logically what numbers you have to add and multiply together. So here is another example. We have 3, 7, 11, 15, etc. And let's say we wanted to find the 32nd term. All right, so what I do is I begin with the equation. All right, I can take term 1, which is 3. Take that first number, then add that with n minus 1. So n is the term number. The term number is 32. So I'm trying to find the 32nd term. So I take 32 minus 1, multiply that by the common difference, which was 4, because we're adding 4 each time. So multiply that by 4. So that would give me the 32nd term. So T32 would equal that, the 32nd term. So 3 plus, this is 31, and then times that by 4. So order of operations, we multiply first. 31 times 4 is 124. Add that with 3, we get 127. So the 32nd term is 127. Now if you want to, if you have one sequence like this and you know you're going to be finding different term numbers over and over again, so like this was the same sequence we just did to find the 100th term, and then we're using this again to find the 32nd term, and let's say you want to know the 120th term or 200th term, and you know that you're going to be reusing the same sequence over and over again. What I can do to make things a little bit quicker is I can plug in things into this equation and get a simpler equation. So here, if we go back to what we had just the Tn right here. All right, so that's an expression to mean just any term number, so just keeping it in general. If we solve or plug in numbers into this equation and keep Tn here to keep it in general, what I'd get is T1 is 3, term 1, and then n is the term number, which we don't know. We want to keep it in general, so keep the n here, and then d is 4. That's your common difference. So what I'd do is I'd plug this in, the 3 and the 4 in, and leave n here because we want to keep the equation in general, so we can use it for whatever we want. Then we can simplify this a little bit. So the 4 can distribute 4 times n, gives you 4n, and 4 times negative 1 is negative 4. So we have the 3 plus 4n minus 4. And then 3 minus 4 is negative 1. So we have 4n minus 1. So notice this would be much quicker to work with if we're going to be reusing over and over again. Because if we did not do this, we have to plug in all these different numbers every time. Plug in, in this case, with a 32, we had to plug in a 3, a 32, and a 4, and then calculate all that. If we keep it in general, we can just plug in the term number. So like here, if we want to find, let's say, the 50th term. So here, once I have the Tn equals 4n minus 1, I can just plug in 50 in for n. 50 is the term number, so I plug that in for n. So T50 is 4 times 50 minus 1. 200 minus 1 is 199. Notice that's much quicker than going through and plugging in all the numbers. We'd have to plug in the term 1 again, we'd have to plug in a 4 again, Instead of 32, we'd plug a 50 in and then calculate all that. So it's a little quicker if we can get to this equation right here. So that way we can just plug in the number n for the term number. But either way you do this, you're going to get the same answer. It's just a matter of which is simpler to use. Okay, here's another example. We are given a sequence of 5, 8, 11, and 14, and you are told to find T17. So this notation means we're finding term 17. What is the 17th number in this list? So what I can do is I start with my formula, and I can plug in things into the formula. So I take the first term, so T1 is going to be term 1, and this is to find Tn. So Tn is the term you're looking for. So to find the 17th term, or Tn, T17, we take the first term, T1. N is the number of terms. So the 17th term means that n would be 17. And then D is your common difference. Alright, so when I plug things in, T1 is 5, that's your first term. There are 17 terms. We're trying to find T17, the 17th term. So n is 17. And the common difference, I'm adding 3 each time. So D would be 3. And then from here I can calculate. 17 minus 1 is 16. Then 16 times 3 is 48. 48 plus 5 would be 53. So T17 would equal 53. And that concludes our lesson for today. We will see you next time.